Okay, so the question is solve the given initial value problem 4y double derivative minus 4y single derivative minus 3y equals to 0, and we have two conditions which are mentioned here, and then we need to find y of x. Okay, so the initial value problem is a second order linear homogeneous differential equation with constant coefficients. Okay, so to solve this type of questions, we have to use an equation called characteristic equation. Okay, so what we do in characteristic equation, we just compare uh, the derivative with something called r square, r, and simple r. So here we go. Let's replacing y double dash with r square and y single derivative with r and simple y with 1. Okay, so that's called characteristic equation. Okay, so our equation will become something like this: 4r square minus 4r minus 3 equals to 0. Okay, so now there are two ways to solve the characteristic equation: by midterm breaking, and the second one using quadratic formula. So I think we can do it by midterm breaking. So yeah, we can do that. So that will become 4r square minus 6r plus 2r minus 3 equals to 0. Okay, so let's take commons. If we take common 2r, that will become 2r minus 3, and from the next one we just take common 1, so 2r minus 3. Okay, so 2r minus 3 into 2r plus 1 equals to 0. So the roots are 2r minus 3 equals to 0, and similarly 2r plus 1 equals to 0. So from here it will become 3 by 2, and the second one will become negative 1 over 2. Okay, so or 1 or 2. Now we have the solution. Since we have two distant real roots which are r1 does not equal to r2, so they are two real and different roots. So the general solution for this type of solution is y of x equals to c1 e to the power of r1 x plus c2 e to the power of r2x. So this is the general form. Now we need to put the values of r1 and r2. Okay, so by putting the values we can get y of x equals to c1 e to the power of r1 is negative 1 over 2 plus c2 e to the power of r2 is basically 3 by 2x. Sorry for forgetting to mention x. Okay, now applying the initial condition. Okay, applying the initial condition, which is initial condition is given in the question, which is when x is 0, y is 1. Okay, So we can find the value of constant c1 and c2 by this. So here let's put x0. So in the general form, so y into 0 c1 e to the power of negative 1 over 2 into 0 plus c2 e to the power of 3 by 2 into 0. So this will become 1, which is already mentioned, and here c1 and something have a power of 0 equals to 1, so I will just write down directly. So c1 plus c2 equals to 1. Okay, so that is equation 1. Okay, now there is a second condition number 2, which is y dash of 0 equals to 3. So first we find the derivative of the general solution. Okay, so the general equation is y of x equals to c1 e to the power of negative x by 2 plus c2 e to the power of 3 by 2 x. Okay, so now let's differentiate on both sides. So this will become y dash of x dy by dx c1 e to the power of negative x by 2 plus c2 to the power of 3 by 2x. Okay, so negative x by 2 plus c2 d by dx e to the power of 3 by 2x. Okay, so if you take the derivative of e power negative x by 2, so this will become c1, and the derivative of e will be always same, so e power negative x by 2, and the derivative of power will become negative 1 over 2. Okay, plus c2, and the derivative of e power 3 by 2x will always be same, and the derivative of the power will be 3 by 2. Okay, so let's just rearrange them. So negative 1 over 2 c1 e power negative x by 2 plus 3 by 2 c2 e power 3 by 2x. This is y dash of x equals to this. Okay, now we can substitute the values. When x substitute x is equals to 0. Okay, so y dash is 3 when x is 0. Okay, so let's put x equals to 0. So y dash of 0 equals to negative 1 over 2 c1 e power negative 0 by 2 plus 3 by 2 c2 e power 3 by 2 into 0. So y dash of 0, we know that that's equals to 3, equals to negative 1 over 2 c1, and e power 0 is always 1. Something have a power of 0 mean 1, plus 3 by 2 c2 1. Okay, so equation will become something like negative c1 divided by 2 plus 3 by 2 c2 equals to 3. Now if you just multiply 2 with this equation, so this will become negative c1 plus 3c2 equals to 3 times 2 equal to 6. Okay, so this is our second equation, equation 2. Now add equation 1 and 2. So our first equation was where? This one. This is our first equation, and this is my second equation. Okay, so add equation 1 and 2. So my first equation was c1 plus c2 equals to 1, and the second equation is negative c1 plus 3c2 equals to 6. By simply adding them, c1 will cancel out, and that will become 4c2 equals to 7, and dividing both sides by 4, so our c2 is 7 by 4. Now we put this in 1 in equation 1. So if you put the value of c2 in any equation if you want, but I just want to put in equation 1, so c1 plus 7 by 4 equals to 1. Okay, so now c1 equals to 1 minus 7 by 4, and if you just take LCM, or yeah, so this will become 4 by 4 minus 7 by 4, 4 minus 7, so c1 equals to minus 3 by 4, 3 by 4. Okay, now the final solution, if we substitute the value of c1 and c2 into the general form, now put c1 equals to, what's the value of c1? Yeah, here, negative 3 by 4, and c2 equals to, what's the value of c2? 7 by 4. In general form, okay, so the general form was y of x equals to c1 e power negative x by 2 plus c2 e power positive positive 3 by 2x. So the solution for the final initial value, the solution for the initial value problem is y of x equals to negative 3 by 4 e to the power of negative x by 2 plus 7 divided by 4 e power 3 by 2x. So that's it.